All right. Well, welcome everybody. Welcome back to the College of Engineering Leadership Seminar Series for the 2022 calendar year. Today is our first day back from a very short holiday break. And so we just wanted to welcome everybody back to see a lot of familiar faces and names from our previous seminar series last year. A lot of new names coming and joining us to this to these sessions. So welcome to all of you. For if this is your first time joining us, I'm Brennan Morioka. I'm the Dean for the College of Engineering. And just again, we want to thank our sponsors, the Hayashida family and Kai Hawaii, for their generous support in providing us funds to help offer our students and our faculty and our community with opportunities like this to listen to leaders in our community, tell their stories, and hopefully that these are some of the experiences that our students can learn as they start and prepare for their next phase in life, as they leave the university into embarking into their career. So really appreciate all of you joining us. Again, always appreciate Ken and Donna Hayashida for their generosity in supporting this seminar series, and also very much appreciative of all of our leaders in our community who participate as speakers as a part of this. And as we start, I am going to turn this over to Mia, who is one of our engineering student ambassadors, to let her kick it off and make some introductions. So Mia.
Hello, everyone. My name's Mia, and with me today is Adam. We'd like to welcome everyone to our first leadership seminar series of the spring semester, presented by the Hayashida family. We've got a great speaker here today, so let's just jump right in. Adam will start off by introducing today's speaker, Patrick Sullivan.
So Dr. Patrick Sullivan is the founder and CEO of Oceanit, and he was named Hawaii's Business Magazine's 2016 CEO of the Year, and also Pacific Business News 2019 Titans of Technology Leader. Dr. Sullivan has occupied seats on the Ocean Research Advisory Panel, appointed by the Secretary of Navy, and also the board of the Pacific International Space Center for Exploration Systems. He's a member of the Hawaii Military Affairs Council of the Chamber of Commerce, and he also successfully developed nationally focused research programs, such as the National Defense Center of Excellence for Research in Ocean Sciences and the National Electric Vehicle Demonstration Program. And both of those were collaborations with DARPA. Dr. Sullivan received his PhD in engineering from the University of Hawaii and his Bachelor of Science in Engineering from the University of Colorado Boulder. Dr. Sullivan developed the methodology of intellectual anarchy, which is practiced at Oceanit as a system of business that kind of breaks down traditional expertise silos and removes management barriers that hinder breakthroughs. So now we'll have Dr. Sullivan begin with any opening remarks that he'd like to share.
No, it's an honor to be here. You picked a great profession. I tell people that are doing engineering, they may end up working as an engineer. They may just use it to help them do other things. So it's a wonderful discipline in critical thinking, and it's a lot of work. But as I've advised young people over the years, it's a great skill set, and you can use it in all kinds of ways. And so it's hard to go wrong with it. Anyway, it's great to be here, and the College of Engineering is really important for all kinds of reasons. It's also quite special, I think, for me, because I spent time there in the graduate program. I saw Bruce Lever earlier on the call, but I learned a lot from the people on my committee and the faculty. It was kind of like a mentorship program. Besides everything, you learn from the learning different techniques and delving, really getting it deep into a technology and putting a big dissertation together and that kind of thing. But it also helps you develop further. And I learned from everybody there. And so I had a wonderful experience. It was a lot of work, but it's never been a problem for me. But I think The College of Engineering is a really important entity for other reasons. In particular, one of the things we're working on is how to diversify the economy in the state of Hawaii, so there's more to do than just tourism. And of course, you can always go work at Pearl Harbor and Indo-PACOM. There's places like that. But if you're really trying to create the future, there's fewer opportunities, and that's kind of why I started Oceanit. I wasn't patient enough to take a job at a university. I didn't want to go to Pearl Harbor. There weren't really many options, so I started Oceanit. And over the years, it's grown. So started it with $100. It just keeps growing. We've got a few hundred people today, maybe 100 PhD level scientists and engineers, and we work across all kinds of disciplines. So as you heard, my undergraduate was engineering physics, but my PhD was in ocean engineering. But yet Bruce, a materials mechanical engineer professor, was my chair. That says a lot about my background because it covered a broad swath of things. Lots of instrumentation, materials, corrosion, data analysis. So this was years before America Online. I was sending data back and forth to the Big Island through the computer network using these old modems, which most of you probably don't know what it is. But if you see the original Matrix movie, you'll hear the sound of what a modem sounds like. And I was moving data throughout the network, learned a lot of interesting things in the process of doing that. And then in starting Oceanit, I built everybody's computer in the beginning because I was able to get the scrap parts from these old Heath kids. So we were probably the first guys in the state where everybody in the office always had a computer. And then we built a network for that just to make everybody connected. So anyway, it's been a wonderful thing for me, a wonderful experience. And again, our goal is to create a more diverse economy, and we are slowly doing it. We've done a variety of private equity finance spin-outs, lots of corporate co-development, a lot of partnerships, and we work pretty much across the world now. You know, it's kind of funny. I was one of our guys. So we have a group in Houston, which, by the way, are mostly Hawaiians, folks that were from Hawaii but are occupying our Houston facility now. And one of the leads there got his PhD at UH, and but we're doing what we call metascale manufacturing and scale up, and then we're using that as a location to go to scale to move materials and equipment around the world, from Italy to India to Abu Dhabi and Dubai and Saudi Arabia and a whole bunch of other places. And all this stuff originated right here in Hawaii from just the folks working together. So anyway, that's kind of my short intro. I've got a presentation I can rapidly go through if all this sounds kind of bizarre, because there is a method to the madness. But maybe I'll leave it at that and see what you guys think.
Oh yeah, we'd love to have you go through your presentation now.
Okay, so I'll do it pretty fast. Let me do share, and let's see, where is it? I just saw it here. Okay, can you see this? Hold on. One second. It's all up. Okay, let me try. I will. It was all working just fine a minute ago. Let's see here.
We can also move to some questions if you'd like to just kind of take some time to prep the presentation.
Sure. Let's start with that. Oh, here we go.
Oh, okay.
Okay. Can you guys see that?
Yep, we can see it.
This
Thank you.
presentation? Okay. All right. Again, so I'm going to go through this kind of fast, but so we call ourselves a mind-to-market company. And what that means is we think of things from fundamental science, and you see on the left, it's a broad idea about where ideas come from in innovation, but it really covers the kind of things we do, from mechanical EE, materials marine biology, astrophysics, all kinds of things. And then we've created these different modalities to go to market. We've done these private equity finance deals, but we've recently done lots of corporate co-development, which is really going, I think, well. And the issue there is that there's very limited or little capital in the state of Hawaii. So we had to create these new ways to bring capital into these things. And that's exactly what we've been doing. This kind of shows you at a high level what it looks like. The left side, the blue zone, is deep science. The right side, the green zone, is human-centered product delivery. And in the middle, you got the rock and roll zone, which is, the ideas in science never quite match up exactly to the products and the people in the field. So we got to work at it. It's hard work to get there too. We kind of break it down into these three zones here of interesting, challenging, and disruptive. And we kind of manage risk, technology risk, execution risk, and market risk. So it turns out most of the risk is in market, about 50%. So you can be too early, too late. Those are the kind of things. And this is how we look at disruptive innovation. So we're looking for things that basically high pain and low certainty. And that kind of puts us in a zone where we launch ideas from basic questions in fundamental science. This is exactly the process, which I'm going to spare you because it takes a little work to go through it. But this thing keeps repeating itself over and over, hence the name of the book. It's not anarchy. It makes a lot of sense. But it looks like anarchy. And the fact is we're crossing disciplines. And, as a reflection of my personal background between mechanical, electrical, ocean, physics, it's kind of how we do things. So this kind of illustrates how we put this together. Basically, ideas, programs, projects, products. So on the left side, you've got risk, and on the right side, you got benefit. On the bottom axis, you got time. So we start with ideas that we look for that are interesting and important. We usually have conversations at the end, last quarter of the year, decide what to do. Then we put programs together with government funding. So we have to match risk appetite. We go to all the different, we work with everybody in the government to take that initial risk. So, you've heard of ONR and DARPA and the FRL, and there's a whole alphabet soup there. But they've got a high risk appetite for high pain problems. And then what we do is at some point we start talking to companies as we, and venture capital can be in there. As the benefit starts looking real and you have products, then you can get more capital into things. And so this process kind of maps it out on a more of a horizontal basis. An example, we started in 2006 in nanotechnology, put together an application for industrial use in shipyards, and have done all kinds of projects around that. And there's a lot of products coming out of that. And some of the products that look kind of promising right now that we're in the middle of HEATX, we're trying to roll this out globally. So first quarter of the year, we'll deploy this in India. Although we've been deploying it now, we've probably done 20 installations. It's with heat exchangers. And ironically, I worked on heat exchangers when I worked on my dissertation, OTEC heat exchangers. Never thought I would do heat exchangers. But what we do is we created this process that changes the surface energy and things slip off it, but it doesn't limit the heat transfer. And it roughly saves about 7% of the carbon and energy in a power plant. So you can take an existing plant, coal, oil, or whatever, and save a lot of carbon and a lot of cost. One of the early adopters was Chevron, but I think we've recently done a bunch of work with the Italians. What's called the Eni, the National Energy Company of Italy. They were here, by the way. They came to visit. They bought an asset in Alaska, and they asked us to put together treat a system for refining, which we did, and it worked really well. Now they're making it their enterprise-wide standard, and they're the big advisor to the Abu Dhabi energy company. But the same company now, Eni, wants to collaborate with us on a whole new hydrogen idea. So they're going to put in a lot of capital on a new idea. And Eni corporate, which is out of Milan, they've become real fans of what we do here. I think we'll have one of the senior execs visiting. The Italians kind of run it, but they're fun groups to work with. But I think they'll be visiting here in Hawaii, and they want to do. The guy's got a talk. He's an engineer, but He's going to give a talk on wine and geology, so I may send the invite. Aeropill, so we started deploying a version of this nanopolymer on aircraft, and turns out we can reduce corrosion. And we started with Hawaiian Air, started actually working with United. We're looking at this as a global standard for commercial aircraft. So it turns out the stiffening piece of these big aircraft like 747, 737, 777, there's these aluminum struts that corrode. They're very expensive to maintain. We think, do a way better job for peanuts, and it's something that's needed around the world. So we just started working too with the German guys. I'm trying to remember their name, but they do maintenance pretty much around the planet on everybody's aircraft. We're doing pipelines, but we're also looking at reducing hydrogen in pipelines. So, or reducing hydrogen embrittlement by putting a treatment on the inside of pipelines, reduces drag, increases throughput. But now the big push is loading up pipelines with methane and hydrogen to reduce greenhouse impact. That looks really good. First one we did was a few years back with Chevron, stopped leaking the methane, had really good results. This is kind of interesting. It's a nanomaterial for making obscuring infrared from drones. So if you're on the ground, you got a drone flying overhead, you can pop a grenade and make everything disappear, which is kind of cool. But we're doing a beauty product in Korea, and hopefully they'll release it maybe later this year. But it turns out the same manufacturing technology which we developed downtown, they're going to adopt, will help scale it up over there. But we actually are doing these kind of small scale and meta scale manufacturing and then going to big scale. We did a Kickstarter on a thermal polymer to manage heat with this vast, started out with a group in the special forces in the military, but we extrude these polymers and then put them in a vest under this brand 19 North, and introduced it last year. We're starting to increase sales. This synthetic virus on killing tumors, we had some really good results with this, which the thing we're doing currently has way more potential. Unobtainium shockwave consolidated material using raster laser nano explosions using nanoenergetics to make material that might be good for Star Trek. Scanite is interesting. It's smart materials. We can put them in all kinds of things. We're building wells. Never thought we'd be doing that in Texas. I think Halliburton just agreed to do a thing for us. And what they're doing is they're creating these wells to sequester carbon and pumping CO2 into the ground. Blast Ninja producing the sound of commercial blasting. We're selling them all over the world. A chip we've been working on for years. We run a fab in the mainland. It's like a synthetic optic nerve. It's got military applications, a lot of other applications. A lot of work in space. Hawaii's got a lot going on in space, believe it or not. Non-invasive deep tissue surgery, underwater broadband, which we're actually doing the demo right now off of Point Panic. But the real project here started with Shell off of Rio in Brazil, where they own the pre-salt 10,000 feet down below. They need underwater broadband. So we've been building this for a few years now. It looks really good. Maybe we're trying to do, I think 100 megabit speed. So, which kind of brings us to one of the things we're doing now, which is these rapid tests. So about 6 years ago, one of the things we launched was a human-style AI using Chomsky and grammar. And then we applied it to medicine to kind of look at this age-old question between causality and correlation. Most medicine is around correlation, but we thought we could look at genetic code and read it more like a language. You know, if you look at what it's composed of, you got 3 billion base pairs, but it's hard to know, but it almost looks like a language. And it turns out we developed the grammar of RNA with the DARPA program, where we can design molecules for purpose and synthesize them with a 3D printer, and then actually produced a test. And now the issue's been getting it to market. I just got the note from the guy in FDA, because I said, what gives? They've had our stuff for a while. It's a really good test. He said they hope to get it by Tuesday. We'll see. And I literally just got that email up about 10 minutes ago because I was asking the director what's going on. But the process to get there looks like this. It's been all over, and it's a long, long haul. But see, what's interesting is you go from the science, then you've got to do manufacturing, and then you've got to do supply chain and clinical and everything else. And the team that's working on that, there's a lot of young people. We have a bunch in their early 30s running these clinical studies around the world. Supply chain management across the world, managing a manufacturing partner. We set up a factory in Korea. And the idea was to build a team in Hawaii that could grow into an application. We see lots of other things to do with this technology. Like we started out looking at cancer. We still think we can do that. This is what the test looks like. We actually eliminated one of these pieces. So that's a quick overview of what we're doing, but it gives you kind of a sense of how we're thinking about it. And there's a book. Let me see if I can unshare. Let's see here. And if you have questions, let me see. Oh, here we go. Stop sharing. Okay. Sorry, that was a lot. Trying to go through quickly, but it gives you an idea what the heck are we doing.
Thank you very much,
And I have to
Patrick.
give a lot of credit to UH.
Yeah, for the next part of the leadership seminar, we're going to have a Q&A portion with Patrick. So audience, feel free to put any questions you have in the chat and we'll get to them as time permits.
All right, so our first question for you. So you wrote a book called Intellectual Anarchy. Could you tell us a bit more about it? And also, you kind of went over this in your presentation, but could you kind of explain a bit more on the components in your book, such as question, think, innovate, deliver, and disrupt?
Yeah, so kind of at a high level, I just gave a talk to a bunch of university guys at the end of the year, 120 universities in California. It was part of the land grant program. They're trying to rethink their whole innovation strategy. But I started out with a slide that shows Hawaii in the middle of the sea, and I call it From Hawaii to the World. So what the book talks about is how we think from Hawaii to the rest of the world. So the world is a market. Hawaii is a wonderful place to live, but the limitations that we had 50 years ago are not the limitations today. We're mostly limited in imagination. And the way science and engineering and technology are moving, there's huge opportunities constantly. And now bringing stuff to market, it's not easy. And I kind of talk about how we do these, how we innovate. We talk about ideas around groupthink. So we're all at risk of groupthink. It's a term in psychology, but basically, you get enough people looking at each other saying the same thing, we all start thinking the same thing. It may not actually be a good view of reality. And I talk about, how we think of finance and how we do partnerships and that kind of thing. So that's really what I cover in the book, but it's a story of Hawaii and how we build a future. It turns out the guy called me to give this talk and at these universities that were at this event, we had the president of the UC system, we had Carnegie Mellon and MIT, and a whole bunch of schools were there, and they were interested in the book. Everybody read it. The guy that called me originally about this was from Rhode Island, and he had found the book and said it was such a compelling story about how to think from the middle of the sea. But it applies to them because we're an island physically, but we're a metaphor for the rest of the country. They're all islands. Unless they can break out of that, they're stuck. And so they liked the book because it gave them ideas about how to unstuck themselves, how to get out of the rut they're in, and to create more competitive innovation. Because part of the driver there was U.S. competitiveness. there's a big push to increase the competitiveness of US technology because we're losing our edge in several areas. Not the first time, but I mean, there's a deliberate push to kind of increase that. Anyway, cover up a bunch of that in the book.
Yeah, thank you for sharing. And I think it's very interesting how you kind of use like your like location as Hawaii as kind of like a means and a method to kind of push that paradigm shift in like in the way you think. That's very interesting.
It was surprising how these guys really liked it because I told them, I said, yeah, we are a metaphor, but you're stuck in the same metaphor. And the way we see it, we can get outside of that and we're doing it. And that's why they thought it was exciting. I think for Hawaii, there's something there for people to learn and to apply because we don't have to just look at ourselves. We can look at the world. And the world needs a lot of help. There's all kinds of opportunities to make the world a better place.
Yeah, so my question to you is, how did you come up with the concept of intellectual anarchy? Was there some experience or event that helped you had like some sort of realization?
You know, I've had lots and lots of help on the way. And sometimes the help comes in very interesting ways. So we started working with the Stanford Design Thinking program several years back because we found that the traditional ways to move things to market weren't working for us. We were in some of these spin-out companies we created, and the traditional ideas of bringing something to market work in a traditional world. But if you're doing something that's disruptive, they really don't. And so the guy that, was running the program at the time, Bill Burnett, said he's going to come to visit, and he was trying to rebuild his program there at Stanford. And so they had followed us at Oceanit. We were working with them, but they said they wanted to learn from us, which I was kind of shocked. But I said, yeah, come on over. So he spent several days with us, and we had lots of conversations around how we do things. So they created a teachable system to sort out how to position technology that's going to be suitable and desirable in the marketplace. But in working with this guy, Bill, over the time, we kind of mapped out how we do this. That's the diagram you saw. But it turns out when you really look at it, it reproduces over and over and over. It's like this evergreen thing. It's constant, and it's creating this pipeline of technology. And so that became kind of the inspiration. I called it intellectual anarchy because it's not the traditional way to think of things. And for starters, we cross fields all the time, right? So we don't think if you're a mechanical engineer that your world begins and ends in mechanical. You can do anything you want. You've got a tool set. And, a lot of these young PhDs we hire, I tell them, the most important skill they have isn't just the knowledge that they put together in their PhD, it's the ability to solve an unsolved problem. That goes on in the future. And so those are the kind of people we look for. But I got to give, when Bill came to visit, I thought, I don't know what to say, right? But he said, no, we want to learn from you guys. So that became the basis of the book.
I think that it's really inspiration that collaboration and working with others was kind of the startup and root of your concept, because I know at the engineering, collaboration is a really important aspect for in classes or labs.
Well, it is critical. We work with about 70 universities around the country, a few outside the country, but and so one of the key issues is working with people, right, in the human side, and everybody's different. So I mentioned earlier I did my undergraduate there in Boulder, and so we're actually collaborating with a guy there, and they're all all these guys share one thing. which I find always remarkable. Just a funny story. We were working with a guy, Art McDonald, before the pandemic. So Art got the Nobel Prize in Physics. He used to be at Yale, and we were at something. We just got to meet him, but I called him up and I said, we want to apply this thing we're working on, this Chomskyan grammar, to basically dark matter. And to my shock, he says, oh yeah, let's try this. And so we started working with him. Same thing, that I mentioned is this interesting guy we've been working with for 6 years, Noam Chomsky. Noam is kind of the godfather of linguistics. He put mathematics and language together. He was at MIT for a long time. And, we throw these crazy ideas out there. He says, that's a great idea. Let's try it. These guys that we work with are at these different institutions, but what they share is this curiosity about the world and the willingness to try something that's outside of their comfort zone, because they think it makes logical sense to look at it that way, in spite of the fact we don't know how the answer is going to work out. And so collaboration is important, but finding these kinds of people, which are also an inspiration to work with. But I just find it remarkable because every time we do it, they say, yeah, let's try this. And I mentioned this guy we're working with in Boulder on these yoctosecond timing systems for some of the quantum stuff we're trying to put together. And it's kind of crazy. I can walk in and find these guys and say, you guys want to try this? And it's like, yeah, let's do this. So it's kind of funny how it works, but we try to find good people to work with. And that collaboration turns out is really important for what we do, because we have really smart people, but there's all kinds of smart people. But putting these teams together, it makes all the difference.
Yeah, thank you for sharing. So kind of as a follow-up, so how do you kind of encourage this method of intellectual anarchy at Oceanit and kind of amongst your employees?
Well, it's an interesting question. So obviously we try to create the environment where they can do this. And by creating the environment, that means creating space for people to have ideas that are outside of the traditional approach. We have innovation fund internally now. We fund ideas and that kind of thing. But what it really comes down to is we try to find inside people this special thing. I don't know how else to describe it, but it's where the head and the heart come together. So the heart is in there because these people are excited to do what they do. I can't pay people to do what they do. They bring what's inside to the work, and it's amazing. I mean, you really can't buy people like this. What you can do is create the environment where they can become amazing. So we try to support people to do amazing things, and they take risks. It doesn't always work, but we learn from what happens. So it's not really failure. It's part of this constant experimentation as we move into something that's really interesting, because usually when you're starting something you've never done, it's hard to know the answer until you did it. And the questions we're usually asking, nobody knows the answer. That's why they're interesting. But creating a space where people can try something that's risky, but potentially remarkable in terms of impact. A friend of mine, he's in DC, he used to be at DARPA for years, and there's this thing we've been pushing, he's been pushing it, but it's to take, it's like an ARPA-H, you might have read about it, it was in the news. Biden has launched his cancer moonshot thing. So it's basically high-risk medical. It's blowing the lid off of the traditional ways of doing things. So the mRNA vaccine, for example, was really not supported by NIH until DARPA took a swing at it, right? You have this risk avoidance with certain institutions. So you go to institutions where they're going to take big risks. So if they put this together in the medical healthcare space, I think they're it's a lot of money for the first year, but the idea is to push people out of their comfort zone and rethink medicine, which we think is really overdue. But it just depends on, you know, where people are, how they see themselves in their lives. Like, what do we do with our time on the planet? So we're trying to do something to make a difference. And so that's an area that'll make a difference. But it took years to get that piece of legislation in. And now, you know, on the president's desk, and all of a sudden, you know, maybe it'll happen. And then we'll try, you know, crazy ideas that could turn into really cool ideas and maybe help a lot of people.
Thank you. Yeah, I like what you said about it's not failure, it's just kind of constant experimentation, because I feel like it's a good mindset to have, especially with engineering, because if you I feel that when I let my failures, like, you know, I'm gonna mess up, of course, and when I do mess up, I have to not kind of beat myself over the head with it, and just remember that there's more chances and there's more opportunities to keep trying, and you can learn from that mistakes that you made and just keep getting better and continue to develop your ideas from that.
Yeah, and experimentation, you know, so we do the theory and we try stuff. A lot of the time, in the first whack at it doesn't work. That doesn't surprise me. What we do, though, is we learn what makes it work. But you can't do some of this stuff without getting your hands on it. That's why having equipment, laboratories, facilities to blow things up, to shoot things, to try things, you'll learn a lot in the process. This hydrogen system, we're starting this project. It's a high energy physics problem, which we worked with some defense folks on directed energy. We thought, okay, what if we tweak it and try this thing and move it this way? So we're not talking about the right space. We don't want to burn anything down. We don't want to blow anything up. But it's going to be way cool. We're going to build a small one here and play with it. And we use the word play because we don't even know what the heck to do with it yet, but we think it'll work. And then this energy company from Italy wants to put a big one in the North Slope of Alaska. So what we're going to do then is, once we get it worked out, we'll build a big one in Houston and then ship it up to Alaska. And if that works, then we see it as an industry-wide solution to a really big problem that all these big companies, all these big energy companies are all interested in the same thing. But these guys are putting up their own capital, and we've been working with them. They're real excited about what we've done with them so far, so they're taking bigger risks with us.
Thank you. That sounds really exciting. So next question is, you mentioned that you'd like to help diversify Hawaii's economy away from tourism. So being Hawaii's leading trailblazer, how do you imagine Hawaii should take the steps to get there?
Oh, I'll try to summarize. So first, I think, trying to get set on what are really important issues. There's an economist who got the Nobel Prize a few years back called Paul Romer, who looked at this idea, and it's called endogenous growth theory. So if you look at the neoclassical growth, which is kind of what we do in the economy in the state of Hawaii, it's really a function of labor and capital, traditional economic idea. So tourism is like a mining industry, kind of parallels that in a lot of ways. Endogenous economics is really about education and innovation. When you plot them out, this is what got the guy the Nobel Prize, was the growth around innovation and knowledge is much steeper when it kicks in. So the first thing you got to do is support education. The most important institution in the state of Hawaii is University of Hawaii. And I think the College of Engineering is one of the most important institutions at the University of Hawaii. But yet sometimes it gets kind of kicked around as though it's sport to do that. And that's not a good look. And that's not a good way for the state to try to make change. So the policies around that need to get kind of refreshed and upgraded. But then, like when we started looking at manufacturing these tests, since we created a whole new technology, we can use like a 3D printer and manufacture the stuff here. Nobody really had put this together yet. We could build the whole thing here. We could train people up in manufacturing. There's an outfit that's doing a test that's very unsophisticated compared to what we do in the process we put together out of San Diego. I think they created 1,000 jobs. A lot around manufacturing because you got supply chain and quality systems, and you got to have people working in these facilities and train them. You could train hotel workers. You bring more engineers and scientists. You got a whole workforce you can build. And these molecules are, lighter than coffee beans, but they're more valuable. But I think the mindset isn't there. And so when we talked to the state, we said, we sure could use some help on a space with 20% humidity or less, because our labs, we just weren't big enough to do this. And it's just not something people are prepared to do because they don't believe that you can do this here. So the more people that believe that the world is different and that times have changed, I think it'll help influence policy in the legislature. It'll influence the way things are managed. And I think what has to happen is things go up and down. I've watched this for a long time, but they need to encourage people to try bigger ideas, take on more risk, to really differentiate the University of Hawaii across the world. And there's tons of opportunities. One of the things we're looking at this year is climate. So not only reducing impact from fossil fuel and that kind of thing, but engineering the planet, understanding how the oceans work as a massive thermostat. There's all kinds of stuff. To give you context for some of you young folks, when I was in Boulder, there was a book called The Limits of Growth in the 70s. I'm giving my age now. Bruce probably remembers this because I think he had family there in Boulder. But Limits of Growth talked about how we're all going to run out of food and die because the resource use population growth was exceeding the ability of the planet to sustain the population. And then along came science, engineering, technology, genetics, and a variety of other things, and kind of changed the way the world did things. So we don't talk about people starving for lack of food anymore. We engineered solutions, and I think we got to engineer a solution for climate and a variety of other things. So no shortage of opportunities, but these are big ideas, and there's risk. People don't want to be wrong. I think creating the atmosphere where you can take a chance on a big idea, maybe not nail it in the first go, but you can bring a lot of really bright people together to solve some incredibly important problems. That'll help move Hawaii forward as well. So university has a huge role to play.
Yeah, I agree with you. Usually with rewards, there's always going to be huge risks that people have to take a step forward and everything. So thank you.
So our next question is from the chat where, so we're just combining the two because one person asked kind of similar things. So it kind of sounds like Oceanit is working in a lot of different industries. So how do you remain competitive in those industries while being kind of a Hawaii-based company? And are there any noticeable differences between the business practices that Hawaii-based companies versus the mainland companies or even international?
That's a good question. So earlier chart that I had on interesting, challenging, and disruptive projects. Interesting projects are things that anybody can do. We do those kind of projects. Challenging are projects that anybody can do, but that are hard to execute. So we did a thing with Amtrak on security around all the train stations around the country a few years back. Hard to execute, but science, security, engineering, all that kind of stuff was part of it. That last category of disruption is probably why people really like us. What we found is that being from Hawaii, I mentioned that a DARPA guy is pushing, a former DARPA guy that was pushing this new high-risk healthcare thing. When he first came to visit, we had worked with him for a while in some projects in DC. He came in the office and said, "You guys are my special forces in the R&D team, universe. Nobody does what you guys do. You push the edges of science and do things people don't think are possible." We became popular because of that. And that's probably why people like to work with us in Hawaii. Turns out people come here from all over. We visit there, of course, and with COVID, there's less travel, but it turns out the power of these ideas and the willingness to look at hard problems is the key thing that really differentiates us. And being in Hawaii doesn't matter. People come from the Middle East, the East Coast, the West Coast, Europe, pretty much everywhere to see us here, which when you think about it is totally whacked. Always surprises me. But they want to see how we do this. And I always am happy to talk to them, but I think the strength of what we do is because being in the middle of the sea, we started with a blank piece of paper. So I mentioned earlier, I got a lot of really good support, a good education from University of Hawaii. But we had to think fundamentally about everything because of where we are. Obviously, a lot of fits and starts, things that worked, things that didn't work. Experimented with raising capital and spinning our companies and, to get to where we are. And turns out our strength is who we are. And the sooner we embrace it, the better off we are. So I tell people they need to be comfortable in their own skin. And by that, I mean, when you've got these young entrepreneurs that go to the mainland and try to raise money, they kind of skirt around the issue that we live in Hawaii. But we don't do that. Maybe there was a time we did, but we don't do that. We said we live in Hawaii, and they say why? And said because it's home. Very simple answer. Everybody travels everywhere. Doesn't matter whether you're in New York or DC people are constantly traveling. And being in Hawaii isn't a handicap like it used to be. So it's got a lot to do with the mindset. So what we find is that these companies, these people we work with, don't seem to hold it against us at all. We just had this group from Department of Defense spend 2 weeks with us. We're doing a project where we pushed, the guy took me aside and he says, this is not even thinkable what you guys just did. He wanted to let me know why it was a big deal. Can't tell you which group he's with, but it's stuff we're doing here. They come and spend time here to kind of work with us because we are who we are, and being in Hawaii is part of the story. So I think embracing that is important versus running away from it, which is kind of a weird thing, but the sooner we take ownership of who we are, faster we'll move things forward. We're not making excuses. We're just trying to do what we think is right. And I think being in the middle of the sea gave us the opportunity to start with a fresh slate.
Thank you for sharing. It's very inspiring to hear that all these people from all over the world, they come here to kind of listen to your ideas and to just kind of learn from a new way of thinking and kind of this thing. So yeah, thank you very much.
Yeah, it does surprise me. I mean, there's a group we're working with. For example, we're going to do a big technology showcase in Houston in May, the biggest energy conference in the world. We've done this now several years in a row. We didn't do one last year, but it's packed. So the group, there's a facility, so we have our own, some labs and things there, but there's a group out of Cambridge that is focused on green energy. They've got all the big energy companies. We're going to set up there. And it's funny because the guys that put that all together, I think they're out of Boston, they wanted to come and visit us here because they were kind of blown away by what we do. And we'll be there in Houston, but again, we don't make geography the issue, but that's the biggest energy conference on the planet. And if we're trying to make an impact in energy, it's good to show up and talk to people. So when we've done it in the past, though, I mean, it's been a packed event. So, for example, that underwater broadband thing I was telling you about, we literally set up a big glass tube 30 feet long at the last one we did 2 years ago. And that was it, right? We were showing a movie underwater, separated by like 30 or 40 feet, doing, 100 megabit or something. And so all of a sudden we had partners, people that wanted to put in money and take the next step.
Thank you. So another chat question is, someone asked if your company is hiring any undergraduate interns.
Every year we do take interns. Last year we kind of stumbled because we didn't have as many because we weren't sure what to do with the COVID protocol because everything kept changing. We have a pretty solid program so we put a lot of work into the internship program. We think it's really important. Been doing it since starting the company 36 some years ago. So, but last year we weren't quite sure. We didn't have as many. So I'm sure we'll do more this year. So what we do is we got a whole process we run them through, but we try to get these young folks comfortable with this idea of innovating something, which it turns out, not a criticism of traditional engineering education, but a lot of the time we get asked, what do you want? Like, what's the answer you're looking for? And I tell these kids, there is no answer. There's just your answer. What do you want to do to make the world better? And it stumps them. Some incredibly great ideas have come from this over the years, these kids. And a lot of them go on to grad school, and some of them come back. So it's kind of funny how that's worked. A lot of these folks, we never really did it as a workforce thing. We did it more as a community thing. But a lot of them come back. They say it's the only place I want to be. So it's kind of surprising. And a lot of super bright local kids that get, they're all over the world and doing their education. But when they come back, they want to be part of this. So it's been really fun and rewarding.
Yeah, it's very cool to know that all these, like, the ideas that these people come up with are new and fresh, and they actually kind of like go somewhere. It's very encouraging for someone like me who's an undergrad and preparing for a career outside of college. So I guess, like, as a final question to wrap up the seminar, and thank you very much for all the insight and wisdom that you've given to us. So what would you suggest that Hawaii, what do you feel that Hawaii needs most from the next generation of leaders, like our generation?
Well, so, we always need, and there's, again, no right answer. There's just your answer. But so we definitely need things, like infrastructure. There's going to be roads, water, ports, harbors, airports. There's tons of stuff like that. That's all really important work. And even in that space, we're doing innovation, right? New materials, inserting artificial intelligence to a whole lot of those kinds of things. But the key thing is to try to think about, what do you love to do? And it's kind of what I tell this younger, like the interns, but is the young kids that are looking at what are they going to do or go to grad school or whatever they're thinking, but try to think about what's in your heart that you want to do, what's exciting, because there's so much to do, but doing something you care about makes a big difference. Everything is difficult. It's a super competitive world, and you have to be ready to work hard, because there's no substitute for showing up and getting in the ring and getting knocked down and getting up and doing that kind of work. But if it's something you care about, it's all a whole different experience. So we suggest that with an undergraduate education in engineering, which is a wonderful, I think, building block. But think about the thing that you want to do, and then again, where the head and the heart come together, it's very powerful. And that's one of the things we've learned, and we try to unlock at Oceanit. But whether you're there or not, it's what you should be thinking about, something you care about, because everything is going to be challenging. I mean, we have to compete with companies all over the world, and but it's fun, So if it's the kind of thing that excites you and you care about it, you're willing to take some hits, you're willing to try some things, you're willing to put in the time, you're willing to try to learn from the best, and it makes it all worthwhile. So that's my suggestion for undergraduates, and I've personally felt blessed that I've been able to do just that.
I'd like to make a comment if I might. Patrick, thank you for a fantastic lecture. I graduated with an MSCE from U of H in 1974. One of my professors, Antares Parvulescu, said you could spend your entire career applying today's technology to yesterday's problems. And another professor, John Craven, and he said, a job worth doing is a job worth doing poorly. And by that, he talked about the supersonic transport where Rolls-Royce bet everything on a new technology on a titanium blade, and they went out of business. So always have a backup plan. Make sure you can do a job poorly, but make sure you can do it. You can always improve it in the future. Most of my ideas, I was an engineering fellow at a major company in advanced maritime technology, but most of my ideas came out of newspapers. When they were talking about cruise liners being blown up, I collaborated with 3 companies. We created a diver detection and interdiction system. When boats couldn't go down the Tigris and Euphrates River, created a command and control system that would know more before anybody else came. So just keep your creative juices going, and your ideas are all around you. Just go from there.
Yeah. No, and Craven was on my committee. He was awesome to work with. And Antares Parvulescu, I haven't heard that name in a long time, but I took some classes from him, worked with him on some stuff. And see, these are really world-class thinkers. And they were part of the program at UH. And I think, they all had influences on me. And you mentioned that, doing it, it's funny, when we did the first version of the underwater broadband, because we were kind of falling behind on schedule, and we had a young group working on it. I said, look, make something as fast as you can that's really crappy and get it out of your system, and then make the next one better. And that's exactly what they did. And actually, it looks pretty good now. But I said, get over the fear, just start doing it. And, they can work with all kinds of really bright people to solve these really hard problems. But it's actually something to be said about that.
Well, thank you. Well, thank you, Patrick. Really appreciate all of your sharing of your experiences and your philosophies on leadership and intellectual anarchy. Is very educational, I think, for all of us, especially for our students. And Kevin, don't worry about the dog. That's life in Zoom these days, right? So. But I appreciate everybody listening in today to hear some of the experiences that Patrick has to share. Really amazing stuff. Patrick, I also like the fact that you mentioned about, understanding of who we are, and being in the middle of the Pacific here in Hawaii is not a handicap, and that it's actually a liberation and empowering to us, especially in light of how COVID has showed us that, being remote is not an obstacle. And so I think that's really empowering to our students in understanding that, being here in Hawaii is actually something to be proud of, and that we can compete and is just as good as anyone else across the world. So appreciate those words. So And again, I just want to, as we close, because we're running up at the edge of the hour, to thank the Hayashidas and the Hayashida Ohana for their support of the leadership seminar series here for the College of Engineering. We have a fantastic lineup throughout the rest of the year. Obviously, you saw it kick off in the right way with Pat Sullivan from Oceanit. But next month on March 4th, we will be having Walter Dodds join us as well. And I think he's going to be able to share a variety of experiences as well. So I ask everyone to come in and listen in on our many fantastic speakers. So once again, Patrick, thank you for sharing today. I hope everybody has a great weekend, and mahalo to everybody for joining us. So aloha and have a good time. Have a good weekend.
Aloha. Thanks. Okay, take care.